Alright, so welcome back again. So in this wonderful and exciting tutorial, we're trying to implement our own higher order function, and our function in this case is going to be reduce. So reduce is one of the three pillars of functional programming. So previously we saw how to work with map. Now let's see how to work with reduce, which is one of the three pillars of functional programming, which is a higher order function. So let's see how and why to use reduce. So reduce is used when you want to apply a function to an iterable, which can be a list, a sum, a list, a set, a tuple, and reduce it to a single cumulative value, right? Very important, single cumulative value. So in case you want to sum all the numbers in a list, right, you can use reduce. In case you want to find the minimum or maximum element in a list, you can use reduce, because in that case you're applying the function called summation to an iterable to produce a single value. So let me show you what I mean. If I come back here, I have, let's say, my list, which consists of numbers like say 5, 3, say 6, say another 6, say 2, let's say 15, right? I have these particular numbers there, right? In case I want to find the sum of them, I can simply do sum my list, and then magically it's going to produce the value 37, right? The magic behind this particular function, right, is the concept of reduce, or the concept of folding, right? So it is behind the scene, it is using folding or reduce to give us this single cumulative value. So it is cumulative because if I add 3, if I add 5 to 3, I'm going to get a particular value, which is going to be 8. Then I'm going to add these two values here, which is 8 to this one, right, which is going to be 14. I'm going to add the remaining 14 to this, which is going to be 14, like 20. Then it moves on, right? Then I'll add 20 to this, 22, then 37. So it is cumulative. So the basic understanding behind how sum works is that it is using reduce behind the scene. So the rule for working with reduce is that it's going to be rules for reduce or folding, right, is that first of all we must have an iterable. So the iterable must be, it can be a list, it can be a set, it can be a tuple, any form of iterable. Then you must pick two values at a time, so 2 values at a time, or x 2 values or x at a time, right? So that means the first one, the first value or the initial value, and then the next value, right? The next value. That's the big understanding behind it, right? Because this one we just pick 5 as the first value, the next value which is going to be 8, then all of these things becomes the initial value, then there's the next value, right? That's the basic understanding, and it must return a cumulative or single cumulative value as a result. That's a basic understanding. So let's see how to use reduce to do that. But before we work on this aspect, let's implement the sum, and then you see how to use reduce behind the scene, right? So let's sum all of these things. So as I said, it must be an iterable. So in case I want to sum all of this, it's going to be, say, for I. So this entire stuff is an iterable already. So in case I want to say my total number, the final result I want, it's going to be 0, right? That is at the initial number that I have, it's going to be 0. I can say, okay, for my element in my list that I have, that is the basic understanding. Okay, pick that particular value. So the noun, so for my element in my list, I want to pick the first value. So this first value, right, is what is going to be picked. Then I'm going to add a first value to the next value. So in that case, it's going to be my total value plus the element, right? Because the first value here is 0. We are starting from 0. Then whatever I'm going to get, I'm going to equate it to the next value. Then now I can now return. So if I run this one, as return, it's not return, but if I go with total, so I'm going to get the same value, 37, right? So how does it work behind the scene? So let's print it out so you see what it is. So print So this is going to be the current value, right? Value that we have now, that we have at the element. Then after that's added all of them, let's print the current cumulative value, or the result now that we have, right? So in this case, it's going to be this option, my total. Let's run it again so that you can see it all. So at the beginning, the initial value of my elements, as you can see from this element that we had, the initial value is 5, right? So let me bring this one down, bring this here. So the initial value is 5, right? So 5 is the first value, that is a current cumulative value. Then I'm going to add that particular value 5 to 0, right? Because 0 is what we started with, and it's going to give us 5. Then 5 plus the next one is going to be 8. So 5 plus 3, right, is going to be 8. Then 5 plus 3 is 8. Then now we are going to add 8 to the next value. So the next value is 6. So 8 plus 6 is going to be 14, right? Then 14 plus the next value, which is 6, is going to be 20. Then 20 plus the next value, which is 2, is going to be 22. And then the final value is going to be 22 plus the next value, which is 15, which is going to be 37. So that's the basic understanding behind it. So it's just picking one at a time, right? Not one at a time. So this one plus this are going to give us 8. Then I'm going to add 8 to this, which is plus 14. Then 14 to the next value, which is going to be 20. Then all of these values to the next value, 22. All of these values to the next value, 15, which is going to be 37. So that's how sum works behind the scenes. So let's write this particular function from scratch. Let me implement our own function. So let's implement our own sum as a function. So def, let's put as my sum. And this is going to be very simple. It's going to take in my iterable, right? And let's give it a start value. So the start value is going to be 0, like as we had here on. And I'm going to say that, okay, my current value that I have, initial value, is going to be the start value, right? And I'm going to say, okay, for my element in my iterable, I want you to pick the initial value and then add it. So it's going to be my initial plus the current element. Then we are going to return the initial that we have. Right, so this is a simple function. So if I run the same function on my list that I have, you must get the same value. So that is how sum works behind the scene, right? So the magic is that we are just looping through, starting from the beginning, looping through them, but whatever result you are going to get is going to be turned back to the initial. Then we are going to keep on adding the elements to it, right? Perfect. So that's how sum works behind the scene, and this is using reduce. So let's work with our own reduce. So this is going to be implement our own reduce. So the first thing, I'm just going to create my function. As I said, it goes with this. So let's go to my reduce, right? It must take in the function, and then must take in my iterable that I have, iterable. Then it must have an initial value. So initial value, in this our case, let's call it as none, right? It can be 0, but let's make it none. Then I'm going to say that, okay, we have gotten this, so let's implement this particular one. So in order for us to get the next value, I'm going to convert this one sequence. Let's convert this sequence into my iter, then iterable. Or let's make it like this. Let's pick this one as sequence, and then we are going to pass the sequence here, converting that sequence with an iterable into an iterable, right? Something like that, so that you get it very well. So that's the first one. Then I can just look through them, and because the beginning of the value is going to be none, we have to fix that error. Let's move straight away and just do it. So for my element in my iterable, just as we had above, right? And then I can just add the value to it. So let's specify the initial value. So let's call this one initial value. You can give it any name, but let's call this let's give it as, let's say, my initial or any other name. So let's call this a value, right? And I'm going to say the current value that we have is going to be my initial value. So we can just do it on this option. Right, perfect. Then we can now apply this function to it. So the simplest way is that you're going to say, okay, that particular value we have is going to be the function that we have, right? The function plus the value. The function is going to work on the value and then the element, the current element, right? And now we are going to return that particular value. This is exactly the same thing we did above here, right? Exactly the same thing. There's no changes. Although the naming, I've changed the name, we probably can still work on the same thing, right? It's still going to work. Perfect. So if I run this one, it's not going to work. It's going to give us an error. Let me show you why. Because of the none, right? So that if I pass in my reduce, and as I said, the rule is that it must take in a function. So let's call that particular function any particular function. So let's use lambda. It must take in the first value and the next value, 2 arguments. And then that argument is going to be my x plus y, then my iterable. If I go with this option, it's going to fail. So why is it failing? Why is it giving us this particular type error? Let's check the error. So unsupported operand type plus non-type, right? Because of the non-type that we had here, we had a non-type here, so we have to work on that. So we can just simply use this option of saying that, okay, if the initial value is none, right, then I want you to give me the next value. So value is equal to next and then my iterable, right? Else equate that particular value to the initial value. That's the basic understanding. So run this now. Let's run it again. Because of this, it's going to face that particular issue. So we have 37, which is exactly the same thing as we implemented with our own custom function, and the same thing that we had when we used Python's default function. Right there. Very nice. But that is, we have seen that behind the scene, it is using a concept of reduction, right, or folding to do the summation, right? And that is how the lambda function works. So this is not just only for sum, but this is for any other function. So the advantage over the reduce is that the reduce option can be used for any particular function that accepts 2 arguments and works on an iterable, right? That's the basic understanding. So 2 arguments and works on an iterable to return a single value. So reduce can be used for summation, can be used for minimization, right? So, or finding the minimum value. So this is how sum is. So this entire stuff is sum behind the scene, using reduce, right? Concept. Now let's do the same thing for, let's say, finding the minimum value. So in case I want to find the minimum value of my list, I have my list here. So find min value. My list is going to be my list, right? In case I want to find the minimum, by default you can see that the minimum value here is 2, but in case I want to find it, I can just go with min my list. Instead we have 2, right? Very nice. I can also do the same thing to find the maximum. It's going to be max my list. So it is still using the same concept, applying a function to an iterable to produce a single cumulative result, which is 15, which is 1. So this is using reduce behind the scene, but this is optimized by default in Python. So min, max, sum, they are optimized by default. But in case you want to implement it, you can do that. So let's implement it using reduce. So we're implementing max using reduce. So from our function we had my reduce, that's the function that we had, right? And then I must pass in my lambda function, so lambda. Then to find the max, that means that the first one must be, we are checking between the two values, so we have x and we have y, right, the first two values. And then what we want to do is that we want to compare them if the first is bigger than the second one. So if this is greater than y, right, that's a basic understanding. If this is greater than y, I want you to return a result. So in other words, it can be like this. Let me write a simple function before we go with the lambda, so that you don't get confused. That is the reason why sometimes reduce is not mostly preferred, because it can be difficult to read. So in case I want to implement it, it's going to be my max value. So I have two values. If I want to implement, I have my values that I want to say a and then b, right? I want to find which of them is greater. So it's going to be, if a is greater than b, I want you to return a, else return b, right? This is how to implement a max function for two values. So if a is greater than b, return a, else return b, right? So if I go back here and I have two values, let's say I have a value like, so my max, or we can call it as find max instead of my max. Find max, maximum value, find maximum value. So let's say I have two values. I have a value like, let's say 3 and then 5. By default, you know that 5 is greater than 3, so it's going to return 5, right? So this is a simple function. So yeah, in case I want to use reduce on this, I can now just come back again and just go with this, my find max. Remember the concept of reduce. Number one, it must work on an iterable. Number two, it must work with a function that takes two arguments at a time. Number three, it must produce a single cumulative value, right? So now I can just go with this option, and then I'll pass in my list. And if I check it out, it's going to do the same thing. You have 15, right? Check out my list. 15 is the stuff. So what it's doing behind the scenes is that it's going to pick the first value, compare this one and this. Okay, this is greater. So since it's greater, it's going to store this. Then this one and this one, which is greater, 6 is greater. Okay, so to store the 6 and 6, which one of them is greater? 6. 6 and 2, which of them is greater? We have 6 and 15, which of them is greater? 15, right? That is a basic understanding. So this is how max is done. So you can also write the same thing using lambda. So write using lambda. So that's going to be the same thing. We're going to have my reduce function that I have. Then I'm going to have my two values. So lambda receives two values. So you see a and b. These are the two values. Then what does it do? So it's going to return. So return a if a is greater than b, right? That means that if a is greater than b, return a, else return b, right? And now I can just pass in my list. This is the same thing we did above here, which is this, right? So this is not maximum, this is minimum. So this is the same thing here. So return a if a is greater than b, else return b, and that's what's given to us. Very nice. So the same thing we did here is what we have done here using a one-liner, right? Using lambda. So this can be difficult to read, so it is mostly recommended that you use for loops or conditionals to do whatever you do. You write it in a function like this, then you just go straight away with this. So this is more easier to read, right, than this one, because this one can be difficult to read, right? That is how max work behind the scene. You can also do the same thing for min by doing the same thing we did above, by just changing the order. So if I go back here, in case I want to do the same thing for the min, all I have to do is just pick this one here. So I want to find the minimum value. So this time I want to find the min. Just go with min and change this one to, so if a is less than b, return b, return a, else return b, right? So this time if I go back and I put find min of, let's say 3 and then 5, it must return 3, right? Perfect. And now I can apply this one to my function. So let's apply it. So it's going to be my reduce, apply my find min to my list that I have. And now it's going to return the minimum value, which is 2, right? Very nice. You can also do the same thing here. So thank you for watching this tutorial. I hope you have learned something. So you have seen and understood the concept of how reduce work. Reduce is very powerful. It can be used to do a lot of things. So it can be used to help us apply a function to a list or an iterable to get a cumulative value. You've seen how to use it on summation. You've seen how to use it to find the minimum or maximum element behind the scene. So the default min and max and sum of Python is using reduce behind the scene, right? That's why reduce have been moved to a separate function on its own. Also, you can also, if I go back and I just do this, so put built-ins and then I do DRL built-ins, you can see that we have the min, max, and then sum as part of Python, but these ones are more optimized. So all of them are using all, and any are all using reduce behind the scene. And let's go back again. Let me show you what I mean. So we see that we have max here as part of the inbuilt function. We have min here as part of the inbuilt function, and then we have length. We also have sum also right here, as you can see. Okay, so that is a basic understanding. Now let's see one usefulness or one use case for sum that for reduce that you don't know. Right, it is going to be bonus tip. So bonus tip. So let's say I have some values. Let's say I have some lists. So let's call this, let's say, names of people, and I want to join them, or let's say an alphabet. So let's say I have an alphabet, or let's say A. Let's say I have this particular value, yeah, and I want to add all of them together, right? I want to join them together. So if I do this, do you think it's going to work? It's not working because these are not integers. But in case I want to join all of them together, I can just do with the normal join function. Join this particular join function, and I pass in the names. If I pass in the names here, because it's a list and it's an iterable, it's going to join them together. So what this join is doing behind the scene, right? This particular join is also using the same reduce function, right? It's using the same folding concept. So it is applying this one to this, and applying this one to this, and AC will be applied to IP and then the rest, right? So I can actually use the same thing with reduce. In that case, it's going to be like this. So my reduce. So perfect. So in case we want to add this one, right? So the simplest approach is that, let me see your solution, right? But let me show you my own solution. It's going to be like this. So I'm going to have my x. That's the first one, and I'm going to add some values to it. So I'm going to say that, okay, I want to join it by space, because here we are joining by space, right? Join by space. Then say that if x else, so see what I did, if s else, you're also going to close it by space plus y. Then now I can pass in my list. So let's pass in the names here. So what you are doing is that we are just applying lambda, using lambda, right? And you're applying this particular function. So I'm just going to pick that particular value, the first value, that is the first value, right? Then if there is no space, if there is a space, right, you just add it to it. That's a basic understanding. So if I run it, so you have A, C, E, the same thing. If I put dot here, I'm going to have it here. In that case, in case I want to apply that particular function, I'll do it in this way. I'm still using the same thing. I'm going to put the dot here. That's the basic understanding behind it. You have seen how we can use reduce to implement this join function, right, in Python. So thank you for watching this tutorial. I hope you have learned something. In case you have any question or contribution, you can put inside the comment section below, and join our Patreon channel for more, and see you in the next session. Stay blessed. Bye.